It begins with the animals. Elk moving out of the valleys in numbers the rangers have never seen. Bison crossing park boundaries in long, silent lines. Then the ground itself starts to speak. First a swarm of small earthquakes, then hundreds of them, then thousands in a single week. The lakes begin to steam, the famous geysers change their rhythm, and in a quiet monitoring room in the western United States, a group of scientists stares at a screen and realizes something no one wants to say out loud. The most dangerous volcano in North America is waking up. Here is the part most people never hear. Scientists have already mapped what happens next, hour by hour, state by state. And today, we are going to walk through it together. Before we go into the eruption itself, you need to understand what Yellowstone actually is, because most people think of it as a park. Old Faithful, hot springs, families taking photos. That picture is true, but it is only the surface. Underneath those boardwalks and forests sits a volcanic system so large that it does not even look like a volcano. There is no towering cone, no smoking peak. Instead, the volcano is the landscape itself. A collapsed crater roughly 30 miles wide and 45 miles long. So vast that early explorers walked across it without ever realizing they were standing inside one of the most powerful geological structures on the planet. Geologists call it a caldera. A caldera forms when a volcano erupts with such violence that it empties its own magma chamber, and then the ground above it collapses into the empty space below. That is what the heart of Yellowstone is. Not a mountain waiting to blow its top, but a scar left behind by explosions so enormous they reshaped an entire continent's weather. And beneath that scar, the machinery is still running. Modern imaging has revealed two vast bodies of hot rock under the park. The upper chamber alone holds thousands of cubic miles of partially molten material. Below that sits an even larger reservoir, feeding heat upward from deep inside the earth. This is why Yellowstone has more geysers than anywhere else on the planet. Every eruption of Old Faithful, every steaming pool, every bubbling mud pot is the surface expression of a heat engine that has been running for millions of years. The park is not near a volcano. The park is the lid. Now here is the history that keeps scientists paying attention. This system has produced 3 catastrophic eruptions. The first was around 2.1 million years ago, and it was one of the largest volcanic events ever identified on Earth, ejecting roughly 6,000 times more material than the eruption of Mount St. Helens. The second came about 1.3 million years ago. The third, around 640,000 years ago, created the caldera we see today and buried huge portions of North America under ash. Notice the spacing of those dates, roughly 600,000 to 800,000 years between the great eruptions. And the last one was 640,000 years ago. You can see why the internet loves to say Yellowstone is overdue. Scientists will tell you that volcanoes do not follow calendars, and they are right. But they will also tell you something else. The system is not dead. It is not even resting, and the region has already shown modern America what it can do, even without an eruption. In the summer of 1959, just west of the park, the ground tore apart in the Hebgen Lake earthquake, a magnitude 7.3 monster that remains one of the most powerful quakes ever recorded in the Rocky Mountains. In the middle of the night, an entire mountainside collapsed, 80 million tons of rock sliding into a canyon in less than a minute, burying a campground, damming a river, and creating a lake that exists to this day. 28 people never came home. That earthquake was not a volcanic eruption. It was simply the crust around the Yellowstone system, adjusting, a shrug, and it leveled a mountainside. Keep that in mind as a unit of measurement, because everything we are about to describe operates on a scale thousands of times greater. There is something else the instruments have recorded in recent decades, something that would sound like science fiction if it were not documented fact. Between 2004 and 2010, the floor of the caldera rose at rates of up to nearly 3 inches per year, one of the fastest uplift episodes ever measured there, an area larger than some American cities, lifting as molten material and hot fluids shifted far below. Then it slowed, then parts of it sank again. The scientists gave this movement a name. They call it the breathing of the caldera, Picture that for a moment. A piece of the earth the size of a major metropolitan area, rising and falling, like the chest of something asleep. The ground inside the caldera rises and falls like something breathing. In some periods, sections of the caldera floor have lifted several inches in a single year. The heat is still there. The magma is still there. The question was never if this system can erupt again. The question is what happens when it does. So, let us answer it. Let us run the scenario that emergency planners and volcanologists have quietly modeled for years. A full-scale eruption, beginning tomorrow morning. It would not actually start tomorrow morning. And this matters. A super eruption does not arrive like a lightning strike. It announces itself. In our scenario, the announcement has been building for weeks. Earthquake swarms are nothing new at Yellowstone. The region records more than 1,000 small quakes in a typical year. But now, the swarms are different. They are stronger, shallower, migrating toward the center of the caldera. GPS stations show the ground rising, not in inches per year, but in inches per day. Roads inside the park begin to crack. Gas measurements show sulfur dioxide climbing to levels no one has ever recorded there. The park closes. Then the towns around it empty. Then, on a cold, clear morning, the northern rim of the caldera fails. The opening blast is beyond anything in recorded human history. Columns of ash and superheated gas punch upward. Not one column, but several, rising through the atmosphere until they stand more than 20 miles above the ground. From orbit, astronauts would watch a gray shield unfold over the American West. From the ground, anyone within dozens of miles would experience something close to the end of the world. Pyroclastic flows, avalanches of gas and rock hotter than 1,000 degrees, pour across the landscape at highway speeds, incinerating forests, filling valleys, erasing everything within a zone that could stretch 50 miles or more from the vents. Inside that zone, survival is not part of the equation. This is the hard truth scientists accept when they model this event. The immediate region, parts of Wyoming, Montana, Idaho, is simply lost. But here's what the models make clear, and this is the part that concerns planners far more than the blast itself. The true national disaster is not fire, it is ash. Volcanic ash is not soft like the ash from a campfire. It is pulverized rock and glass, hard, abrasive, heavy. A single cubic yard of it can weigh as much as a car. It does not melt like snow. It does not wash away like mud. Whatever it lands on, it stays on, until human hands and machines physically remove it. Shovel by shovel, truckload by truckload, cities that have lived through even minor ash falls describe the cleanup as the disaster after the disaster. And a Yellowstone super eruption would produce enough of it to bury the heartland of America. Government scientists have modeled exactly this, a month-long super eruption, and mapped where the ash goes. The results are sobering. Cities within about 300 miles, Billings, Casper, Idaho Falls, buried under 3 feet or more, Salt Lake City and Denver, measured in inches to feet, and the cloud keeps traveling. Ash falling on farms in Nebraska and Kansas, ash dusting the streets of Chicago, measurable ash reaching Los Angeles, Houston, even New York, both coasts, touched by the same eruption. Now, walk through what that actually means for the country, because this is where the scenario stops being a movie and becomes a systems problem. Start with the air. Jet engines cannot fly through volcanic ash. It melts inside the turbines and turns to glass. Within hours of the eruption, aviation across North America shuts down, not reduced, shut down. Compare that to a single medium-sized eruption in Iceland years ago, which grounded flights across Europe for days from a cloud a tiny fraction of this size. Now, imagine that situation, multiplied across an entire continent, lasting weeks or months. Then the power grid. Wet ash conducts electricity. It flashes across insulators and shorts out transformers. Across the ashfall zone, substations fail one by one. Ash clogs air filters. So, backup generators choke. Water treatment plants, which depend on both power and clean intakes, begin to fail as ash turns reservoirs to gray sludge. The roofs come next. 4 inches of dry ash adds tons of weight to an average roof. Wet it with rain or snow, and roofs across hundreds of miles begin to collapse. Hospitals, schools, warehouses. Now add the human layer. Volcanic ash is brutal on the lungs. The fine particles are essentially microscopic shards of glass. Across the ashfall zone, tens of millions of people would need masks, filtered air, and shelter at the exact moment that supply chains stop moving. Highways disappear under gray drifts, and even where roads are passable, ash destroys engines that drive through it. Emergency planners describe the core problem in one sentence. It is not that help does not exist, it is that help cannot reach you. Every disaster response America has ever mounted, hurricanes, wildfires, floods, assumed that the rest of the country was fine and could send trucks. In this scenario, a third of the country is inside the disaster, and the trucks cannot drive through it, and the financial shock arrives before the ash even settles. One widely cited estimate puts the direct damage of a full Yellowstone event at $3 trillion, roughly a fifth of the entire American economy. And analysts who study catastrophe risk will quietly tell you that number is conservative because it cannot capture what happens when insurance markets, crop futures, and the housing stock of a dozen states are all hit in the same week. There is no playbook for that. No country has ever written one. And then, the food. This is the consequence that turns a regional catastrophe into a global one. The ash does not fall on empty land. It falls on the most productive farmland on Earth. The American Midwest grows a huge share of the world's corn, wheat, and soybeans. Even a few inches of ash smothers a growing season. The livestock are hit just as hard. Animals grazing on ash-coated grass grind their teeth down and ingest fluorine-tainted material. One bad harvest year in the American breadbasket moves grain prices worldwide. The models suggest this would not be one bad year. Recovery of the soil could take years. In the hardest hit zones, decades. Which brings us to the sky itself, because the finest particles and the sulfur gases do not come down. They rise into the stratosphere and spread around the planet, forming a veil that reflects sunlight back into space. After the Great Eruption of Tambora in 1815, a far smaller event than what we are describing, the world experienced the year without a summer. Crops failed in New England and Europe. Snow fell in June. A Yellowstone supereruption injects many times more material. Climate models suggest global temperatures could drop noticeably for several years. Shortened growing seasons, failed monsoons, food stress on every continent. Sunsets would turn strange and red worldwide, the one beautiful signature of a wounded sky. And the world that emerged from those cold years would be reorganized, politically, economically, agriculturally, around a single question. Who can still grow food? No country escapes a supereruption, not one. That is the scenario. Now let me pull you back, because this is where I refuse to do what some channels do. I am not going to tell you this is about to happen. It is not. And the scientists who monitor Yellowstone every single day are clear about that. The probability of a supereruption in any given year is tiny, on the order of 1 in 700,000 or lower by most estimates. The observatory that watches the park has stated plainly that the volcano shows no signs of an imminent catastrophic eruption. The ground breathes, the quakes swarm, and the system remains, for now, in its long sleep. But here is what makes Yellowstone worth your attention anyway. 3 things the calm headlines leave out. First, a supereruption is not the only weapon this volcano has. Scientists consider large hydrothermal explosions, steam blasts that can excavate craters hundreds of feet across, and lava flows far more likely than a caldera event. Those would be regional disasters, not national ones, but they sit on the same restless system. Second, the warning time is a genuine unknown. The optimistic view says a supereruption would telegraph itself for months or years, exactly the buildup we described. But the rock record has complicated that. Studies of crystals from ancient eruptions suggest some supervolcanoes moved from quiet to catastrophic in decades or less. A blink in geological time. We have never watched a supereruption begin. No human ever has. The first one we observe will be the first one we observe. And third, the monitoring itself is the real story. Right now, as you watch this, a network of dozens of seismometers, GPS stations, gas sensors, temperature probes, and satellite instruments watches every tremble of that caldera floor, 24 hours a day, every day of the year. When a swarm of earthquakes rattles the park, and swarms happen constantly, analysts do not just count the quakes, they map them in 3 dimensions, watching whether they migrate, whether they shallow, whether the pattern matches moving fluid or shifting magma. Satellites passing overhead measure the rise and fall of the ground down to fractions of an inch. Instruments sniff the air above the basins for changes in carbon dioxide and sulfur. Every one of those measurements is compared against decades of baseline data, because the entire science of eruption forecasting rests on one principle. You cannot recognize abnormal until you deeply understand normal. Yellowstone is one of the most watched pieces of Earth on the planet, precisely because everyone understands what sleeps underneath it. If the giant ever stirs for real, these are the people who will know first. And the signals we walk through at the start of this video, the swarms, the uplift, the gas, are exactly what they are watching for. So, where does this leave us? Let me give you 3 futures, because that is the honest way to think about a system like this. The first future, and by far the most likely, is that nothing happens in our lifetime. The caldera keeps breathing, the tourists keep coming. Yellowstone remains what it has been for centuries. A beautiful, steaming, slightly unsettling national treasure. In this future, the video you are watching is simply education. The second future is the middle path. Sometime in the coming decades, the system produces a smaller event. A hydrothermal explosion near a popular basin, a new fissure, a lava flow crawling across a corner of the park. Dramatic footage, a closed park, a shaken region, and a sharp global reminder that the sleeping giant is real. Scientists consider this the most plausible form of Yellowstone activity, and, honestly, it would change how America thinks about the ground it stands on. The third future is the one we walked through today. The full event, vanishingly unlikely in any year, but never impossible, because it has happened before, 3 times, in this exact place. And if the warning signs ever do begin, the scenario you now understand is the playbook that emergency planners will be holding in their hands. Here is my honest opinion, after everything the research shows. The danger of Yellowstone is not that it will erupt tomorrow. The danger is that it operates on a clock so much larger than ours that we mistake its patience for peace. Human civilization, agriculture, cities, the entire modern world has existed inside one short, quiet chapter of this volcano's life. The scientists watching it are not alarmists. They are the reason we would have any warning at all, and personally, I find that more reassuring than comfortable. Because the truth is simple. We do not control this system. We only listen to it. So now I want to hear from you. How far do you live from Yellowstone? And had you ever realized what is actually sitting under that park? Drop your state in the comments. I read everyone. And I want to see how many of you are inside that ashfall map. If this changed the way you see American ground, hit the like button. It genuinely helps this channel grow. And if you want to know which fault line scientists fear more than any volcano, a fault most Americans have never even heard of, subscribe and turn on notifications, because that story is coming next. The ground beneath America is speaking. Make sure you are listening.